Okay, let us write a C program for a timer based on interrupts. Okay, working based on interrupts. Okay, so we will use the same problem like what we had demonstrated earlier. So let me open the slide. So we will generate a square wave with a frequency of 10 Hertz in P1.5. Again, we have done this in assembly language, but right now we'll do that in the C program. So the way to do it is first include reg51.h 51.h. okay, then we'll say void main void. Okay, so here we need to enable the interrupt. So let us see what are the different interrupts that we have at our disposal. Okay, so window, okay, so this is timer. Let us open one more, a recent document entitled 2. Okay, so interrupt enable, that is what I would be interested in. I need to enable timer 0 interrupt, so that is this bit and EA. So it is going to be 10000010, so that is 82. Okay, so let us go back to Keil and so many windows. Okay, so IE is equal to 0x82. okay, so I have set EA as well as the timer 0 interrupt. Okay, now I will load the value of TH0. I'll first set the T mod timer into mode 1. Okay, and then I need to set TH0 and TL0 as 4B FD. TH0 is equal to 0x4B and TL0 is equal to 0x FD. Okay, so then I will run the timer. R0 is equal to 1, and then I will wait in an infinite loop. Okay, that's the while 1 statement. Okay, so let me see again. I have set the timer interrupt, I have enabled the timer interrupt and EA. Then I have set the T mod in 1, that's the mode 1, timer 0 in mode 1. Then I have loaded the delay corresponding to 10 Hertz. Okay, and then I'm running the timer. Now I have not implemented the timer interrupt. So first let me create a data type S bit, S wave is equal to P1.5. so I'll be toggling the value of P1.5. then void timer 0 void, so I am implementing an ISR. Now timer 0 is interrupt RRUPT 1. okay, so then here I will toggle S wave, SWAVE is equal to tilde SWAVE, and when the timer overflows I will reload the value of timer with the 4B and TH0 is equal to 4B and TL0 is equal to FD. Okay, so let us compile this program and let us run this. So there is a syntax error. Okay, P1 cap 5. Okay, so sometimes assembly instructions and C instructions are mixed. Okay, let us run compile this, no errors, and let me now put the session in the debug mode and and remove the breakpoint. If at all there is a breakpoint, I'll remove the breakpoint. I don't want that. And I am running my program. I stop it and I'll zoom in and let me set a reference here. Okay, and let me go and check. Okay, if you see here the delta, let me reset the reference again. I'll set the reference here, right over here. Okay, again the reference deviates from what I intend to. Okay, so let me go back. Okay, good. And let me measure the delta time from. Okay, so it is approximately 0.1 seconds, or the frequency, if you see, it is 9.97 Hertz. Now let us extend this problem further. What we will do is we will generate 10 Hertz in P1.5 and some other frequency greater than 10 Hertz at P1.2. Okay, so I will define SWave1 as P1.5 and SWave2 as P1.2. Then I am going to use both timers, timer 0 and timer 1. Timer 0 will provide a delay corresponding to 50 milliseconds to generate a square wave of 10 Hertz. Now timer 1, we will set it to some other arbitrary value that is lesser than, that provides time period lesser than 50 milliseconds, maybe something like 0x AB, just an arbitrary value, TH1 and TL1. Okay, and I will enable not only timer 0 interrupt, I have to enable timer 1 interrupt also. So timer 0 is the bit number, it's next bit to LSB, and timer 1 is the most significant bit of the lowermost nibble. So it is 1 0 0 0 0 1 0 1 0. So this is timer 0, this is timer 1 interrupt, and then this is enable EA, so it should be 8A. okay, so my interrupt enable pin should be 8A. I'm putting both the timers in mode 1, and I'm loading some value in timer 0 and loading some other value in timer 1. Then I am running TR0 and TR1. Okay, I have implemented the ISR for timer 0, so let me also implement the ISR for timer 1. Timer 1 interrupt number is 3. Okay, so with that we'll also load the default value in TH1 and TL1, and we will change this method signature to timer 1. So let me see the program again. I have to make the modifications in timer 0 as well as timer 1. I will be toggling P1.5 in timer interrupt 0 and toggling P1.2 in timer 1 interrupt. So let me see the program. Both the timer interrupts are enabled and both the timers are in mode 1, and T0 delay corresponds to 50 millisecond delay, and T1 entry correspond to some delay with lesser than 50 millisecond. Okay, and then both the timers are running. Now ISR of timer 1 will toggle P1.5 and reload the 50 millisecond delay in timer 0. ISR of timer 0 will toggle P1.5 and reload T0. ISR of timer 1, that is interrupt 3, will toggle P1.2 and reload the value of t1. Okay, so let us compile this. Okay, and let us run this as well. Okay, so I think I need to set the set up the logic analyzer. I had to set one more pin, that is p1.2. okay, and the range for p1.2 is minimum is 0 and maximum is 2. Okay, and highlighted in green. So let me run this now. Okay, so let us go here. The timer 0 is running with the time period of approximately 0.1 seconds or 10 hertz. That's fine. And timer 1 is now running with the with the time period of approximately 46 millisecond or 21 hertz. Okay, so this is the demonstration of the timer in timer interrupts, and that too where multiple timers are running and the interrupts are triggered. Whenever the timer overflows, the interrupts are triggered.